their volumes are normally distributed with a mean of 150 and a standard deviation of 5 mils. 5% of the cartons are rejected for containing of too little juice. Find the minimum volume to the nearest mil that a carton must contain if it is to be accepted. Alright, so if it's normally distributed, so what should we do first?
On a graph.
Draw a little graph. What's this middle number?
150.
And standard deviation is 5. Okay. So now this is where we have to try and think common sense, read the question, and decide where we're going to draw our little line. Okay. So it says 5% of the cartons are rejected for containing too little juice. So straight away, where is my line going to be? Left. Okay, so we know it's over here somewhere. Yeah? 5% are rejected. So we're going to draw a line here, and we're going to shade that. Yes? And we're going to put that in as a probability. Now remember, the probabilities as we put them into the calcs are decimals. So what's 5% as a decimal?
0.05.
Nice. Okay? This is the kind of situation where under test pressure, a little bit of excitement, sometimes people put 0.5. Okay? So you've got to be really careful when you're doing this. Okay? Please make sure that you're remembering to divide by 100.
Wait, how did you know it's on the left?
Because it says that they're rejected as containing too little juice. Okay? So if your mean's 150 and you haven't got enough juice in there, it has to be over this side of it. Yeah? So we need to find the minimum volume that a carton must be if it's to be accepted. So obviously we're trying to find this value here. Yeah? So the minimum volume, so that means it's the smallest amount that we are going to accept this value. Tres viets. So we're going to get our calcs. Oh, hang on a minute. Done. All right, so is this going to be normal distribution or inverse normal?
Inverse.
Why?
Because it's on the side of the packet. IDC.
More- Okay, so I said, is it going to be is it normal distribution or is it inverse normal
Because we
distribution?
have to find the x, right? Yeah.
Yes, okay, we're happy with that. In the question, they've given us the percentage. Now, you may be thinking, yeah, okay, that's obvious. Once you come to an actual exam question, that's the kind of question you have to ask yourself. Is it normal distribution or is it inverse normal distribution? What is so funny, Cameron? Oh. Sound like you were giggling. All right, okay, so what am I going to do for my area?
0.05.
Nice. Sarah is on the ball. Mean
150.
and le standard deviation.
Wait, that's 150. No, 142.
So I got 142 to the nearest mil.
Yeah.
Did you get that too?
I got 141.
Yeah, but to the nearest milliliter. So we.
That's x.
So that's the value of x. Yeah.
What did we put in red?
These are the numbers here. Look, 0.05, and then 150, 150, and 5.
I swear these kids are.
That's it. Done. Easy peasy. Oh, shush now. Wait, Miss Harrison.
Equals this Harrison.
What am I waiting for, darling?
Never mind, keep going.
Okay, now this is where it starts getting trickier. Okay, these ones, oh, maybe this one isn't. Okay, let's read the question carefully, Miss Harrison. Okay, you may be also given cumulative probabilities and asked to find it either mean, or yes, or standard deviation, or both. Shush now. Right. Sacks of potatoes with mean weights 5 kilos are packed by an automatic loader. In a test, it was found that 10% of bags were over 5.2, and use this information to find the standard deviation of le process. Okay, what are we going to do first? Draw a graph. Nice. We're going to do that for all of them. And we're going to be so good at drawing our little normal distribution bad boys. Okay, what we're going to put as our mean. Nice. So it says 10% of bags were over 5.2.
To the right side.
So to the right, obviously, well, I'm hoping you're all comfortable that 5.2 is bigger than 5.
Yeah.
And 10% of bags are over that.
So to the right.
So I'm going to shade this baby here, yeah? So that's 10%. What oh, well, not what, I don't mean that. Nice, thanks. Okay. So that's all the information that we have with the normal data. Okay. Our problem comes in here is because we don't know the standard deviation and we need to find it. Okay. So what we have to do now at this point is remember we met this formula up here. We haven't really done anything with it up until this point. That's where these kinds of things come in. And I have to say, I hate to break it to you, but these kinds of questions are becoming more and more popular. Okay, so what we now have to do is we have to redraw our diagram using our standard normalized data. Okay, so for the standard normalized, remember, this value is always 0. Our standard deviation is always what? 1. The diagram is going to look the same though. Okay? But this here is now, bless you, representing a Z-score. Okay, you're happy with that? So let's just assimilate what's happened. We filled in all the information we could with the real numbers. But because we don't know the standard deviation, we wouldn't be able to use the calculator to do it. Okay? The only way we can use our calculator is by inputting information for the standardized normal. And what that does is that enables us to find this number here. But from the information on this diagram, we know that this Z represents 5.2. Yes? And then we would use this formula here and rearrange it to find the standard deviation. Okay, so we're going to finish it off, but just make sure that you're comfortable why we're doing it. When we're inputting stuff into the calculator, which area do we always input?
Left.
From the far left. So what area are we going to input?
0.9.
0.9. Love it. I love your work, people. I love your work. Oh, I lost the chair. Okay, so we're going into our calcs. We are going inverse norm. Oh, we're at 8 minutes already. Quick. Okay, inverse norm. We're putting in 0.9. Our mean, what's our mean? Oops.
5.
Careful. 0, yes. And what's our standard deviation?
1.
Nice. I'm loving it. So we've got 1.28. Oh, what was it?
1.38.
1.28. Okay, so that's our Z-score. So now we're going to use that formula because we know that 1.28 is our Z, and that's equal to X, which is our data value. Which data value did it represent? This one here. Yes? Take away our mean. What's our mean? Our actual mean. 5. Divided by our standard deviation, which is the thing where they've asked us to find. Okay? Pardon? Now, no, so we used the standard normal in order to be able to find this Z-score. Because the standard normal, the standard deviation for the standardized normal is always 1. So we could put both of those bits of information into the calc, because in the calc, the calc only tells us these numbers at the bottom. But we already had it for this question, so it was no good to us. So what we did is we used the calc to find the Z-score, because we knew the standard deviation was that, and then we're using this formula to rearrange. Now remember, when your unknown is on the bottom and you want to find it, you just switch these two babies. So we've got standard deviation is 5.2 subtract 5 over 1.8, which is 0.156 trillions.